problems, we let z equal to the sum of the Pij times the Xij, and we also replace the Xij times z with the Yij, and we also relax the Xij. So we convert the original integer fractional problem to a linear programming problem. And solving this linear programming problem, we can get the values of all the binary variables. The binary variables is Xij, and after we get this values, we can fix the largest Xij is equal to 1, and remove the related constraints, and we go to the step to solve the linear programming problems until we can fix all the values of the binary variables, and then we will resolve this the sub-problems to maximize the power efficiency and get the result. And then if we find for the two sub-problems, so we find that more than one Xij equal to 1 for the same I. It means that one user to group with the multi-mobile things. So we need to decide which group the user belong to. So we compare all the power efficiency of all the sub-problems, and we find the maximum one, and the maximum one Xij will keep maximum one sub-problem will keep the Xij equal to 1. After we set all these binary values Xij down, and we can resolve the original problems, and we can get the solutions. And in order to evaluation the performance of our problems, we do some simulations. The first simulation is that we compare our proposed gradient algorithm to other algorithms along to the different numbers of the users. The nearest algorithm means that the users is always grouped with the nearest mobile things. If their distance is nearest, they are grouped together. If the nearest mobile thing to the user, the distance is beyond 200 meters, it means that this user will group will not group to anyone. And the random algorithm, it means the group is the random selected. We can see that our proposed gradient algorithm is the best of the all three algorithms, because we have a better strategy to choose which users and which mobile things will group together. And the nearest algorithm is the next one, which is better than the randomness. It's because it also has a strategy to how to group the users and the readers, but it just considers the distance. It doesn't consider the power or the data or the some constraints. So its performance is the second better one. Is not good than the gradient algorithms. And the second, we compare the power efficiency as the density of the mobile things increase. we can see that along with the mobile, the density of the mobile things increase, the performance of the gradient algorithm and the nearest algorithm, they all improved. This is because if it has the more mobile things, the users have the more opportunities to group of the opportunity to group with the mobile things. But we can see that the gap between the gradient algorithm and the nearest algorithm, the gap is remained. Maybe the difference is not too much. Because that even the opportunity of the group with the mobile things has been much more. But for every users, even the number of the mobile things has been much more. But the options to choose, choose which mobile things to group with each other maybe still limited. So the gap is not big. And the third one, we just compare the total power along with the power density and not power. We just compare the total power along with the user's number and also the mobile sync density. We can see that our gradient algorithm is very stable, no matter the change of the user size or the change of mobile sync density. It shows that our proposed algorithm is a scalable algorithm. It's a stable algorithm. So finally, through this project, we first proposed a novel TDM-based ad hoc networks to track the target in the public area. After we use a TDM method to get the user's information from the tags, the mobile things would based on the data or the user's location to decide whether they need to directly to send the data to the users. And the second one, aiming to maximize the power efficiency of the things. Mobile things will formulate an optimization problem to find optimal groups for the mobile things and the users. Since this is a sum of ratio problem, we develop a heuristic algorithm, gradient algorithm to solve this problem. And through the extensive simulations, we show that our gradient algorithm is effective in improving the performance of the networks. And this is all about my work. Thank you.